Okay, hopefully this should be working. Let's see if we can get some people in here. I'm gonna send the link real quick to the Discord. All right, we have Matthew Bidwell. Let's go. David Hovey, let's go. All right, we've got some people here. Okay, so I have the live chat set up. Oh, okay. Now that I'm thinking of it, okay. How am I gonna make this work? Okay, so I have the chat here. So I'm going to go through this test. I'm not going to go through the super easy ones like number one, number two. You guys don't need to see that stuff. But the ones I am going to go over are like the just most like the calculus and statistics, plus maybe some of the problems that there's just like quicker ways of doing it. So, um, actually, one second. I need to grab my Inspire. So I can work on this. Okay. Hey, would you mind you guys send what kind of calculator you use? Um, hopefully you guys use Inspires because I'm going to be referencing that a lot. If you use 84s, a lot of the TI Inspire and TI 84 stuff still applies. But honestly, I haven't used a TI 84 since like junior high, so I won't be as well versed in it. So I'll be checking the live chat like in between problems, and so okay, so you use a TI 84. Okay, that's good to know. So a lot of the statistics things still apply. I'll try to do my best to show. Okay, Inspire and HP. Okay, that's good. HP Prime, or do you use like an HP 35? So yeah, so I'll try to keep the questions um as like accessible as possible. So like I'll still show some of the Inspire shortcuts, but for people that use a TI-84, I'll do my best to keep it um, keep it accessible, if you know what I mean. All right. I wasn't able to get a PDF of the test, so hopefully you guys have copies of the test, and if not, I'm going to okay, HB 35, nice. Um, I'll kind of be working some of the problems, uh, but I'll still be what am I trying to say? Giving you the gist of the problem, even if you don't have it right in front of you. So hopefully you'll still have an idea. So I forgot to click the channel. Live stream number 2, not 3, 2. All right, sweet. So I'm looking through this. Number 1 is about Joe and Arlene taking their children to Fuzzies. That's a pretty basic problem. Number 2 is just a basic you're plugging and solving. Number 3, let's see. Number 3, you're finding the equations of lines. And by the way, if I skip one, like if I go past a problem and you're like, oh, maybe that's not so obvious, then I'm willing to go back. I just don't want to be solving all these problems and then have you be like, why are you doing these? It's no one wants to hear this. Okay, okay. So, all right, good warm up. We can start with number 5. Good. Hopefully everybody has their tests with them. So this says a good approximation for a person's maximum heart rate. Oh no, where's my? Oh, there it is. A good approximation for a person's maximum heart rate is given by MHR equals 220 minus X, where MHR is the maximum heart rate in beats per minute and X is a person's age. Randy recently ran a 3-mile run in 30 minutes. He ran with his heart rate at 85% of his maximum heart rate, and his heart beat 4,080 times during the run. How old is Randy? All right, so this is what we can do. So we can find his beats per minute here. So this is pretty straightforward. Beats per minute is just the number of beats divided by the number of minutes, right? So 4,080 divided by 30 is 136. And it tells us that that's 85% of his maximum heart rate. So maximum heart rate times 0.85 gives you 136. And so his maximum heart rate divided by 0.85 is 160. So not M, but MHR. Same thing. And so looking up here, if your maximum heart rate is 220 minus X, then he must be 60 years old. Okay, that was a good warm-up problem. Nothing too difficult, but I also didn't want to skip straight to the calculus just because, that's I don't know, it's just not the best way to start. All right, let's see if anyone has mentioned anything. Nope, we're good. Okay, moving on. Yep, so for those of you joining, if I skip a problem that you want me to go over, just go ahead and say something, or if part of my explanation doesn't make sense, then you can also send something, and I'll go back. All right, let's see. Number 6, Salem left Canadian and traveled north. Okay, this is like a Pythagorean theorem type problem. If you guys want to, we can go over it. I have the live chat set up on my phone so I can kind of see how it's going. All right, 7 and 8 were the first ones that I was really hearing people missing. All right, so this says given h of x equals the square root of x over the square root of 16 minus x squared. And number 7 wants you to find the domain of h of x. So let's say we have square roots, which tells us whenever we have square roots, we know that the domain is going to be restricted because the things that are the square roots have to be greater than 0. Or greater than or equal to, rather. So x is greater than or equal to 0, has to apply for that top one. And then for this bottom one, 16 minus x squared also has to be greater than or equal to 0. So if we solve this inequality right here, let's see. So 16 minus x squared is greater than or equal to 0. So 16 is greater than or equal to x squared. Yes, and so x squared is less than or equal to 16. So x has to be between -4 and +4. Right, because anything outside of that, if you square it, you're going to get more than 16. But we also have this inequality here, with x is greater than or equal to 0. Combined with this inequality, -4 is less than or equal to x is less than or equal to 4. And so this part from -4 to 0 is going to kind of be canceled out because these both have to be true. So this is going to turn to 0 is less than or equal to x is less than or equal to 4. And this is actually where a lot of people made mistakes because they forgot one little thing. They saw the square roots and were like, oh, my square roots had to be greater than or equal to 0. But they forgot that this part in the denominator also cannot equal 0. And when does this equal 0? Well, 16 minus x squared equals 0 when x is equal to 4. And so the actual answer to this is 0 is less than or equal to x is less than 4. There's also another way you can do this for those of you with an Inspire that I actually learned about kind of recently. It's not really that useful on this problem, but sometimes these get pretty complicated. If you actually just type the word domain, into your calculator, it'll go from like the italics to like the straight up and down, like you have a function. And then in your domain, if you'll type your function, so like this, comma x, you'll get an output that will actually give you your domain in interval notation. So you click enter, and it'll actually output 0 is less than or equal to x is less than 4, which is pretty nice. Not so much for this problem, but sometimes those questions, yes, get pretty complicated, and if you're short on time, this is definitely a surefire way to get some good points. Okay, the next problem that they ask is, it's pretty related to this, it's just finding the range. So the range, so if domain is all the available x values that you can put in, your range will be all of your available y values. Okay, so there's something to notice right away. Actually, I'm going to scroll down instead of erasing, just in case someone wants me to go back. Okay, so I'm going to mark. Actually, I'll mark all the questions in red. That way I can go back. Okay, so then number 8. Say for the 84, I just graph and look at the table if they're tricky. Yeah, that's pretty good. Um, yeah, obviously the Inspire can do things that the 84 can't, but you can still do really well with the TI 84. And sometimes I know some people use the TI Inspire, and then they get like really reliant on the Inspire, and so sometimes people that use those actually do worse on like the higher level tests, like region and state, whenever McCurdy like makes the problems more tricky and more calculator proof. So you might actually be doing yourself a favor. I don't know. All right, but number 8, we have the same equation. We have oh, I'll go back to writing in black. We have h of x equals square root of x over the square root of 16 minus x squared. So let's see, what can we do here? Oh yes, and we want to find the range. That's important. And remember, the range is just all your possible y values. So because we're taking the square roots on top and bottom, it's assumed that it's called the principal root. It's assumed that whenever you take the square root of things, it's always going to be a positive number. So you take a square root of, I mean, okay, unless you're taking the square root and it's 0, but it's going to be non-negative. So the square root of x has to be greater than 0 unless it is 0, right? So it's going to be greater than or equal to 0, and the bottom one is also greater than or equal to 0, right? So, uh, so yes, once you get outside of the domain, it's not going to work. So like if x is 5, for instance, right? We've already established that that's outside of the domain. But for the numbers that are on the domain, 16 minus x squared will always be positive. So this is the first thing we recognize. If we have a positive number over a positive number, we instantly know that we're not going to have any negative values, which, in fact, the answer choices kind of take care of for those of you with your test. But this is still nice. We know that there's going to be positive values. And so let's think about what happens whenever, okay, if our domain is from 0 to 4, okay, for non-inclusive, right? But that's okay. So at 0, what is this going to be? So at 0, the square root of 0 here is going to make the entire fraction 0. And so we can say that that's part of our range. We're not sure if that's a lower or upper bound, but we know that's going to be part of our range. So one of them is going to be 0. And let's see what happens whenever we increase this number. So if we go to 1 or 2 or 3, or we can't get to 4, but say like 3.9, right? This number, the square root of x is increasing, albeit it's increasing pretty slowly. But what's happening in the denominator, as you're getting closer and closer to 4, is this 16 minus x squared is getting closer and closer to 0. And what happens there is, say you're using like x equals 3.99, then the denominator of your equation is 16 minus 3.99 squared, which when you take the square root of that gives you 0.2826. And you know what happens when you divide by a number less than 1? You're going to get a number, like your quotient is going to increase. And so as this x gets closer and closer and closer to 4, this number in the denominator is going to get smaller and smaller and smaller, which is going to make the whole fraction bigger and bigger and bigger. So your range here, you're going to have a lower bound at 0, and you're going to have an upper bound at infinity as x is closer and closer to 4. Okay, so that's the end of number 8. I'm just going to check out the chat, make sure everything's going smoothly. Yeah, for the TI-84, I just looked. Oh, yeah, we've done that. 7 concurrent viewers. This is great. Okay. I don't remember how much we got onto in the other one, but this is still good. All right, let's keep going. If anyone has any requests, please say something. We're gonna be doing some of the more tricky ones, and if I skip one that you want me to do, then I will come back to it. Oh, right, I'm not erasing. Okay, the next one I'm gonna do is, let's see. Oh, number 13. This one's not very tricky, but there is a quicker way to do it that some people may have overlooked. So it says triangle ABC is similar to triangle DEF. And as soon as when I'm taking a test, as soon as I see that, I get out my scratch paper and I draw these triangles really big. The bigger your triangles, the bigger your diagrams, the higher chance you have of getting it right. I know it sounds stupid, but it actually works. All right, so I got ABC, and it's similar to DEF, so I'm going to align it so that my corresponding vertices look the same. Okay, I have a request for number 12. I'm going to go ahead and finish number 13 first, and then I'll get to that. Okay, so ABC, it tells us that AB equals 24, BC equals 18, and AC equals 20, and then EF equals 15. And it wants to know the perimeter of triangle DEF. So, we're trying to find the perimeter of triangle DEF. For those of you that do calculator, you may recognize this as something you would see like on number 46. And what I mean by that is you can use scaling principles. So my similar sides, they go from 18 to 15, which is multiplying by 5/6. And so because of that, I'm going to be multiplying each of my sides times 5/6. So instead of finding each individual side, multiplying it by 5/6, and then adding them together, what you can actually do is find the perimeter of ABC, so 18 plus 20 plus 24, and then just multiply that by 5/6. So 18 plus 20 plus 24 is 62, and then times 5/6 is 51.7. So I'm not sure how much faster that is, but well, let's just say you're trying to find areas. You can find the area of this triangle relatively easy. There's multiple ways of doing it. But you could look at the scaling and multiply by the factor squared, and that would save you from having to find all of these other sides. Okay, I have requests for number 12, and I have requests for number 10. So the number 10 is earlier in the test, but that number 12 came in earlier, so I'm going to go ahead and do that one. Okay, so number 12. Okay, find the area. Okay, so we're going to do this diagram before. Okay, let me do my best to draw this circle. Okay, not the best thing in the world, not the worst thing in the world. Okay, so it's circle O, and A, C, looks like these are connected. And then you have this diameter, DB. Okay, and what does it tell you? Chord AC intersects BD at point E. Okay, fair enough. AC is perpendicular to BD. Okay, that's important information. BD equals 20, AC equals 16. Okay, so BD equals 20, the diameter equals 20, which tells us that the radius is going to equal 10. And AC equals 16. So from here to here is 16. And it's important to know that if you have a radius with a perpendicular chord to it, it's always going to bisect that chord. So if AC is 16, we know that AE equals EC, which is 8. And then let's find the area of sector AOD. So, okay, so here's how you would do it. If your radius is 10, then AO is also going to equal 10. And the way you can find the area of a sector is just by using the fact that it's just part of a circle. So if this angle right here is theta, right? If we could find theta, then the area of the sector is just theta over 360 multiplied by pi r squared. This is the full circle. This is like the fraction of the circle that we're trying to figure. And we found what r was earlier because r is just half of BD. So to find that angle, we can look at this triangle right here. Okay, so this angle right here, I'll call it alpha just so I'm not repeating myself. We can find that angle because we have this 8 and this 10. We can say the sine of alpha equals 8 divided by 10, which would give us alpha equals inverse sine of 8 over 10, which is... My calculator just turned off. Okay. Not 140. 8 over 10. Okay, which is 53.13. And looking at this diagram, we see that alpha plus theta is going to be 180. So we can see that theta will be 180 minus that. So theta is 126.87. And then plugging this in over here will give us the area of our sector. So that over 360 times pi times 10 squared gives us an area of 111. Oh, nearest 10th, 110.7. Yep, there we go. Okay. Hopefully that was good. We're going to go over number 12 now. Matthew Bidwell wants me to go over number 12. Oh, wait, that's the one I just did. My bad. Kai Miller wants me to go over number 10. I can definitely do that. This one is a little tricky. It's just because there's just so many words in this problem. There's so many words in this problem that you get kind of messed around. Okay, so it says, hopefully you guys have your test because this is about to be a lot of words. Matthew Bidwell says, thanks, you're welcome, dude. Okay, in Southeast Ohio, the number of cougars in a protected area varies directly as the number of acres varies directly as the number of acres the area covers, and inversely as the square of the number of grizzly bears in the area. See, just people read that and they're like, why am I even doing this problem? Okay, this is what it's saying. You guys have probably, I'm assuming you guys were all in high school. I don't know that for a fact, but I'm assuming that. And you've probably seen just your basic, like direct and inverse variation. So for direct variation, your constant is going to be y over, is going to be the quotient, right? Your constant is going to be y over x. And for inverse, your constant is the product equals x times y, right? And so this is just like a combination of those two. We're trying to find what this constant is equal to. So we have k, which is just, I'm using k as just my constant. It says the number of cougars in a protected area, so I'm going to see C for cougars, varies directly as the number of acres. So in my direct variation, my constant is just the quotient of those two. So I'm going to have a in the denominator, and then, okay, directly as the number of acres the area covers, and inversely as the square of the number of grizzly bears in the area. So when it's inversely proportional, the product of them makes the constant. And so it's inversely as the square of the number of grizzly bears, so it's times b, number of bears, squared. So this is going to be our constant. The next sentence of the thing actually gives us the way to calculate this constant. It says, the protected area in Teton County covers 600 acres, has 88 cougars, and has 12 grizzly bears. So the constant, there's 88 cougars, 12 grizzly bears. How many acres? 600 acres. That's K. Well, by definition, K is a constant, right? That's how we set it up. And so we can use that to solve for the other one. It says if the protected area in Fremont County covers 964 acres, so that's the denominator, 22 grizzly bears, so times 22 squared, then we can solve for the number of cougars. And when you do it, you don't get an exact answer, but you get like 42.0 something. It's really, really close. Yeah, but you get C equals 42, like that. So the trickiest part is just coming up with this equation. And once you have this, then you can do the whole thing. And then you can do it for, say, it like varies inversely as the log of the number of grizzly bears, or e to the x of the number of grizzly bears, right? Like, you'll probably never see that, but as long as you understand this thing with direct variation and inverse variation, then you'll be able to solve any of them. Okay, so hopefully that was a good explanation. I see we have a regional champion in the live chat right now. Tony Wang. Not sure if I should be helping you right now, but my team didn't advance, and you know what? Yeah, we'll do it anyway. Why not? Oh, dang it, I'm not erasing. Just in case. Just in case. What problem was that? Number 10? Yes. Okay, so we'll go over number 39. This from a lot of people skipped on the test, and I was talking with Justin on the Discord, and he was like, um, "There's a really easy way to do this if you have an Inspire. If not, there is still a way to do it, but it's kind of annoying, and it kind of takes a while. So I'll try to show both ways. So number 39. Okay, the graph of here. I'll just write the equation: 4 sine theta plus the square root of 16 cosine squared theta plus 16 sine squared theta all over 16 cosine squared. Yeah, this is kind of a huge fuller equation. But there are some simplifications you can make right away. So first of all, in the square root here, um, I'm going to isolate this a little bit. If I factor out the 16 of here, I get 16 times cosine squared plus sine squared, or cosine squared theta plus sine squared theta. And this is what's called the Pythagorean identity. This is always going to be equal to 1. You can look more into that, but for right now, that's always going to be equal to 1. And so that goes away. And then it's just the square root of 16. So this can be simplified to 4 sine theta plus 4 equals, or sorry, 4 sine theta plus 4 over 16 cosine squared theta equals r. Then I can take away my 4's. Oh, and by the way, the final, okay, I need to actually give context. It says it's a parabola in the form y equals ax squared plus bx plus c, a plus b plus c equals. So it's in the form ax squared plus bx plus c. We want to find a plus b plus c. Okay, so there's two ways of doing this from here. There's the n-square way, and then there's the slightly, what I think is the more creative solution, but definitely the slower solution. Okay, anyway, this is the n-square way. So you just have to use some of your substitutions. For example, you know r equals the square root of x squared plus y squared. You know that y equals r times the sine of theta, and x equals r times the cosine of theta. So I'm just going to take this, make these substitutions, and then solve for y. So my r is the square root of x squared plus y squared plus 1 equals 4 times x over r squared. And if you have an Inspire, this is pretty easy to simplify. If you don't, it's pretty annoying. But I haven't personally tried to get through this whole thing, but I imagine it's not nice. Actually, you know what? Let's just do it. All right, so the square root of x squared plus y squared. And then, let's see, how is this going to simplify? Y over r plus 1. Okay, let's just multiply the top and bottom by r and see what happens. So on the top, I'll get y plus r. Then the bottom, that's 4x squared over r squared. So I'll get 4x squared divided by r. So instead of dividing by r in the denominator, I'm just going to multiply by r in the numerator. But then r is just the square root of x squared plus y squared, so I can cancel it with this. So 1 equals y plus r over 4x squared. And 4x squared equals y, or r plus y. Feeling like I did something wrong. But okay, anyway, if you have an Inspire, you can solve it. But here's the way that I found to solve it without it. So here's what you do. It has to do with the fact that it asks for a plus b plus c. So you guys have probably done number sense and seen like these sum of the coefficients questions. Like you were trying to find the sum of the coefficients of like x plus 2 times x plus 3, right? You could just multiply it out, actually find the parabola, and then just say 1 plus 5 plus 6 gives you 12. Or what us number sense pros do is we just plug in 1 in for x. So that's exactly what I'm going to do. I have r equals sine theta plus 1 over 4 cosine squared theta. So I'm going to multiply the 4 cosine squared theta over like this was sine theta plus 1. Then I'm going to multiply both sides by r because when I do that, this turns to r squared cosine squared theta. Well, I know r cosine theta equals x. And from this, since I'm finding a plus b plus c, I know x equals 1. And so this on the left just all simplifies down to 4 equals r sine theta plus r. And then let's see what else. We know r sine theta is equal to y, also from this. And then r equals the square root of x squared plus y squared. Well, once again, we know x equals 1. So this is going to be 1 plus y squared. And then from here, you just solve for y, and you get y equals 1 and 7/8. So that's kind of long, but also, I don't know how many of you have Inspires. That's definitely an advantage in certain cases. I think this is the way that Justin over at Clements did it. I skipped this during the test because I saw, oh, big scary polar equation, to be completely honest with you. so, yeah. Hopefully that helped. I'm not sure how much delay is on this stream, to be honest. So, it's possible you guys are typing right now and I've already moved on. I'm sorry if that's the case. I have it set up right here so that hopefully I don't miss anything. Okay. Taking requests at this point. If I skip one, we can go back to it. If you want to do one of the calculus ones because you don't have a lot of time, then we can skip that. Whatever you guys want to do. Literally just doing what the chat tells me. Okay, numbers 14 and 15. Nothing too remarkable there. You just have to know that the radius and the tangent line are perpendicular. And then from there, it's relatively straightforward. Find falling points are the vertices of a right triangle. Slopes are perpendicular, right? Length of the longest median. This does take a little bit of insight, but not too bad altogether. So number 17. Some of you guys might even have programs for this. I don't know. All right, so consider triangle DEF with D equals 13. And this is probably not going to be to scale because the sides are so close together. But I'm just going to draw it approximately as an equilateral triangle. So DEF, D equals 13, EF equals 15, DF equals 17. So let's see. d equals 13, ef equals 15, df equals. Oh, yes. So the way I thought of this is I thought about like the extreme case. So I'm like, what if my triangle looked like this? You know, what would be the length of my longest median? Well, it kind of makes sense that it's going to be the one opposite my smallest angle, which will be the one opposite my smallest side. And so it's going to be this, this median right here. And how can we solve for this? Well, we know this length is 17. We know this length, I didn't draw it very well, but this is actually going to cut this in half. That'll be 6.5. And then all we have to do now, if we can find this angle, then we can use law of cosines to find this median. Well, so to find that angle, we'll say 13 squared plus 17 squared minus, this is just law of cosines. I'm not going to go over this. Cosine theta equals 15 squared. And I don't think I have it written down what that angle is. But okay, if you just bear with me for a second. 360 to... Hopefully it's like 58.18 degrees. Hopefully that's right. And then the median will just be law of cosines, but now with 6.5 and 17. So, so our median squared will be 6.5 squared plus 17 squared minus 2 times 6.5 times 17 times the cosine of 58.18 degrees. And let's hope that this worked. And yep, you should get 14.7 whenever you solve through this whole thing. This might be a nice program to make. I don't know how he could change it that much. It would have to be kind of a flexible program because he could give you like, I don't know, maybe he gives you like 15 and 17 and then like this angle and wants you to solve for the length of the longest one. But I guess if you did that, you would just have to solve for ED or DE and then just use your program. So I guess that wouldn't be too bad. Yeah, you could still do that. All right. Let's see what else is being asked. Number 48. We'll see. Well, see if I answered number 48. Oh yes, I actually was looking at. This is from Tony Lang once again. I was actually looking at this problem earlier today, and I actually found a faster solution. Actually, maybe this faster solution is what you did originally, but faster than the way I did it for sure. Okay, so number 48. And if anyone else is joining me, just if there's one you want me to go over, just text and not text, post on the live chat. And when I'm done with all the other ones in the queue, we'll just get to yours. All right, so this says let x and y be functions of time. So you got x of I keep forgetting to change the code. Let's see, I've got x of t and I've got y of t. They both vary based on time. And they're related by the equation 3x squared plus 2y squared minus 6xy equals 99. And when I solved this at first, it was very annoying. I derived with respect to t, and I had like implicitly derived everything, and it kind of sucked. What I did this time, though, was I instead of finding like dx dt and dy dt, I found dy dx. Actually, okay, sorry. I keep forgetting that people might not have their test in front of them. Okay, it says at the time t equals 2, x equals 3, and y is less than 0, and dx dt equals 6, find the value of dy dt at time equals 0. Not time equals 0, at time equals 2. There we go. At time equals 2. So I'm actually going to solve for dy dx in this case. One, because there's a way really inspired to do it, and that's the calculator I use. And because I just think it's easier and takes less time. So even if you're not doing this with the Inspire. First of all, for those that don't know, if you go to menu 4E on your TI Inspire, you can actually just type in this equation, do comma x, comma y, and it'll give you dy dx. But I'll still show it for those of you that don't, or I don't know if the TI-84 can do implicit differentiation. I'm honestly not sure. If someone could text me that, or I keep saying text. If someone could send that on the chat. So if I derive this dy dx, so 3x squared would just be 6x. This would be 4y dy dx. And then this xy is kind of annoying, but that's okay. So it would be f prime g times fg prime. So if I derive just x, I get 1, and so that's going to be dy dx plus, wait, what did I just do? Derivative of that times that plus, no, that's just y. Hold up. Derivative of x is 1 times y, and then x times the derivative of y, which is x times dy dx. There we go. That was a little bit of a brain fart. Okay, TI-84 can't do implicit. Okay, that's a good thing I'm showing this then. So equals 99, so equals 0, because derivative of a constant is just equal to 0. So you have to isolate your dy dx, which this on its own can take some time, but it's still quicker than having to use like a system of equations or plug in all this stuff. So minus 6y minus 6x dy dx. And then if you solve for dy dx, you end up with 6x minus 6y, I'm trying to do this in my head, over 6x minus 4y. So simplify everything, 3x minus 3y over 3x minus... Let me double check this. This is plus y. I made a mistake. Nope, looks like I'm good. Okay, so what this tells you the slope at a certain point, x comma y. It tells you dy dx. Well, there's a part of, for those of you that have done like parametric stuff, you'll recognize that if I have dx and I have dy, dx dt and dy dt, I can actually find dy dx relatively easily. So I actually don't have dy dt quite yet because I know x equals 3, but I don't know what y is. And so I would actually just plug it back in here to find what y is. So I'm kind of running out of space, but it's okay. So if I plug in x equals 3, I can find what my y is at this point. It's 99. And remember, it says y is less than 0, so keep that in mind. Equals 99. Oh, excellent. Okay, so you get y equals negative 3. There you go. And so from that, x equals 3, y equals negative 3. You can find what dy dx is. So dy dx equals 3 times x, which is 6, minus 3 times negative 3. And then 3x would be 3 times 3 minus 2 times negative 3. And that all gives you, I mean, there's a reason that this is on the regional test. This is going to take a while. This equals 1.8. Yeah, and then for those of you that have done parametric stuff, you probably recognize dy dx is equal to dy dt over dx dt. And if you're trying to find dy dt, you see that dy dt just equals dy dx multiplied by dx dt. So dy dx we just found is 1.8, dx dt, it tells us in the problem, is 6. And I did something wrong because this, oh no, I can't remember what I did. Please someone tell me where I messed up. Let's see, dx dt is 6, dy. Wait, did I just do this wrong? Oh, I see what I did. I just substituted wrong. Look, right here. That's supposed to be 3x, and instead of x, I put in dx dt. So x actually equals 3 right here. So 3 times 3 minus 3 times negative 3 over 3 times 3 minus. That's more like it. I get dy dx equals 1.2. And so that just changes this right here. So I get dy dx equals, not dy dx, dy dt equals 7.2. So that's not super quick. It is faster, in my opinion, than deriving with respect to t, but still, I mean, it's hard. You got to be fast on your calculator and just good at math in general to get that into time frame. Okay, I think we're gonna go until like 8 o'clock. So we're just gonna get in all the ones we can till 8 o'clock. If anyone has any more suggestions or wants me to go back, all right. If we got nothing else, then I'm just gonna keep going. Um, the next one I think people got tripped up on was number 23, and it's just because he hasn't really used this wording before. It says the graph of a cubic function has a local minimum at 7. Yeah, Tony, yeah, it looks like it's just gonna take a while. Maybe we can, I mean, I bet there's some people smarter than us that can figure out how to do that quick. But the thing is if we figure out how to do it quick, he can just change like one little thing and then it could all just go away. I do wonder if there's a way the Inspired can do it. System of a differential equation. I wonder if actually I do wonder if the Inspire can solve differential equations, but implicitly. Wait, hold up. Sorry, bear with me, guys. I just had an idea on stream. Um, okay, I'm gonna have to look into this later. This might be a way of doing it, actually. I might be able to leverage this differential equation solver. Okay, we're gonna go back. We're going back. Okay. Okay, yeah, we're gonna go back to 23. Uh, and like I said, I think this is just like a wording thing that got people tripped up. This question is actually kind of easy. Okay. The graph of a cubic function has a local minimum at 7, -4. Actually, I'm gonna draw this axis straighter because this is gonna bother me. Okay, even that's not great. But whatever. So we got a local minimum at 7, -4. That is not 7, -4. Maybe like right here. There we go. And a point of symmetry at 0, 6. Now this is the thing that I think people are like, what in the world is what in the world does that mean? Um, but pretty much what it means is, I mean, you look at a cubic, and sometimes whoa. Okay, you guys know what a cubic looks like. It has some like line of symmetry right here, where if you reflected it across, this thing would turn into this thing, which is not a very rigorous way of saying that, but so you guys kind of know what I mean. Okay, so it tells us there's a local minimum there. So it's gonna look something like this. So local minimum, and then symmetry, and then maximum, somewhere up here. And this line of symmetry is just saying, not this line of symmetry, this point of symmetry is just saying if you reflect 7, -4 over 0, 6, you're going to get to this point. Well, to get from 7, if we do x and y's independently, to get from x equals 7 to x equals 0, subtracting 7, so this point must have x coordinate of -7. And then to go from -4 to 6 is 10, so I just add 10 here. And then I think it wants like the sum of the coordinates. Yeah, a plus b. Yeah, so this is just 9. Yeah, so I think some people got tripped up on the wording there, but not too bad. I'm really gonna try to say her name. Anahita Malhotra says, "Is this live stream going to be available later?" Yes, I'm pretty sure that after the fact, this worked for my other live stream. I'm pretty sure that after the fact, I can post this, and it's gonna be a long video. But luckily, I'm putting these red things, so hopefully, whenever you're scrubbing through the video, it's easy to see which question I'm on. Oh, we want to see number 56. Okay. 23. Okay, we just finished 23. I was going to go to 24, but we can skip to 56. What is number 56? Hopefully, I have a good way of explaining this. Oh, sweet. And I know I'm helping you guys out, but honestly, being able to be live and like try to explain the stuff on the spot really tests me to see whether or not I actually understand these questions. Because um, if I can't explain them, then I obviously don't know them very well. That's a good tip. It's a good math study tip. In fact, my friend that does computer science, um, he has like this lobster. He has like this plastic lobster that whenever his code's not working, he'll like talk to his lobster, and it'll like help him see where the mistake in his code in his code is. I think it's called like rubber ducking or something. Um, Maybe you've heard that before, but it kind of works just with regular people. Not saying that you guys are like plastic lobsters or anything, but I mean, it's a good way of practicing. On to the actual question. Coronado High School has had the same four runners on the mile relay the last 2 years. The times and seconds for all four runners over the last 2 years are approximately normal with means and standard deviations shown in the table. Assuming each runner's individual times are independent, that's the important thing. Find the probability that the total team time at a randomly selected track meet is less than 195 seconds. Okay, so I'm going to have to write out this table a little bit. So you got Bruce, you got Keenan, you got Kelly, and you got Joe. And here's the mean, here's the standard deviation, and it's going to take some time to write out, and if you guys all have your tests, then I don't really need to do this, but I don't know if everyone has their tests, so 0.4, 1.1, 0.6, and 0.8. And it wants to know the probability that the total team time at a randomly selected track meet is less than 195 seconds. So basically you have all these different distributions, right? Each one of these people has their own distribution with their own mean, their own standard deviation. And there's a pretty simple way of combining them. So if you're trying to find the mean of all of them put together, this is a pretty basic question. So for two people, it kind of makes sense, right? Say I can run it in 30 seconds because I'm that fast. Say I can run it in 30 seconds, and Tony over here is just trudging along, takes him 70 seconds. It kind of just messing with you. Anyway, let's say it takes him like 70 seconds. So together, our average time is going to be put together. It's going to be 30 plus 70, which is 100, right? And so that kind of makes sense. But for four people, the same thing kind of extends. So to find the mean for the total, like for all of them put together, you just add all of these numbers. So 48.8 plus 50.2 plus 49.7 plus 48.2. So you get a mean for the total of 196.9. And then for the standard deviations, it's a little bit weird. It's what some people call the Pythagorean theorem of statistics. And it comes from the fact that you can't just add standard deviations, but you can add variances. And there's a very convenient formula for this. The standard deviation squared is equal to the variance. And so to add these, right? To add these, you're going to have to square all of them so that they turn into variances. And this will give you the variance of the entire team. And then to find the standard deviation of the entire team, you just take the square root of that again. So you can see how if you had two people with standard deviations A and B, how it would look kind of like the Pythagorean theorem. But it's not really a Pythagorean theorem, it's just a convenient way of remembering it. Anyway, when you do this, you should get 1.54 for your standard deviation. So your mean, 196.9. Your standard deviation is 1.54. And then it wants to know, find the probability that the total team time at our unrestricted track meet is less than 195 seconds. So at this point, it's just a normal CDF, right? You have a normal distribution, and you're trying to find the probability that you have something on a certain range. So I'm not 100% sure where this is on the TI-84, and I'm really sorry. I think there is like a distributions tab. I just don't remember how to get to it. But on the TI Inspire, you go to menu, 6 for statistics, 5 for distributions, and then you'll see 2 is for normal CDF. Then my lower bound, okay, so it's going to give you options for lower bound, upper bound, and then your mean, which is that little U symbol, and your standard deviation, which is the sigma, the little circle with the line. And so you want to find the probability the total team time is less than 195 seconds. So your lower bound. Okay, Matthew Bidwell says it's in distributions second variables. Okay, so anyone with the TI-84, look at that. So your lower bound, since you want it to be less than 195 seconds, you just use negative infinity, or you can use like negative 99999 if you want. And then so that's your lower bound. Your upper bound, you want it to be less than 195, so your upper bound has to be 195. And then we already solved for the mean and standard deviation, like that. And then you type all these things in, and you should end up with 0.11. There you go, 0.11. So, nothing too crazy, but still a nice question. I'm expecting him to ask something along these lines on the state test, just because it's already come up a couple times this year. So I think if he likes his little Pythagorean theorem statistics, it's kind of a funky little looking thing. I wonder if anyone's made like a geometric proof of this, like why you can add variances and not standard deviations. But I actually haven't looked into that. That's actually pretty interesting. Okay, we want to look at number 37. To be honest, I don't have a good way of doing 37. 37 kind of just took me a while. And honestly, it's probably one I should have skipped, because I spent a lot of time on this one just because I knew I could get the answer if I worked on it long enough. But yeah, but I had to. It cost me in the end. This test took longer because all the geometries. But it says consider the sequence. Consider the sequence 3, 7, 12, 18, 25, 33. Find the sum of the first 20 terms in the sequence. Let's see. So what can you do? I can't actually remember how I solved this one. Well, first of all, you have to find out what kind of pattern this is. And it looks like it's not going to be arithmetic, because you got 4, and then 5, and then 6, and then 7, and then 8. So it's not arithmetic. But the second differences, Ooh, Matthew Bedwell. Okay. For the 84, you can do a quadratic regression of the terms of the sequence and then summation with that formula. Oh, wait, that's actually really clever. I completely forgot I had a quadratic regression on this thing. I actually, oh my gosh. Okay, that's okay. That's okay. And Kindler, that's what you did too. Man, all right. I wish I had thought of that earlier, but okay, I know it now. Okay, this is what they're saying. If you have the Inspire or if you have the 84, hopefully you know where quadratic regression is. You go to your stat calculations, make a quadratic regression, make your X list like 1, 2, 3, 4, 5, 6, and then 3, 7, 12, 18, 25, 33. And then what you'll find, it'll give you an equation, and then you just take the summation of it from x equals 1 to 20 of f of x. Like you'll get an output that says like f of x equals something x squared plus something x plus something. I do wonder if there's a quicker way of doing it, but without it being, I don't know. I think that is the best way though. I mean, McCurdy does say that he likes people to make use of their calculator, so maybe that's the kind of question he's talking about. Okay. Oh man, I wish I thought of that. Okay, I used a lot of time on that question. Okay, what's the next one? What's the next one? This test wasn't like especially hard. I just needed like 10 more minutes to finish all the problems. My speed was a little bit off. Okay, let's see. The next one we can look at. Um, my teammate did a sum of a sum, and that. Oh, that's also interesting. Yeah, that's pretty cool. Sum of a sum. Okay, let me see if I can find another one. Could do number 28. Are you guys good with those? Maybe not. Um, point to a plane. Distance from point to a plane, maybe. What else do you guys want to see? Um, mean value theorem. Number 46 was interesting. You had to actually know this formula instead of just using the program. I feel like there was another one that was tricky on here that I'm skipping. Can you go over 32? Yes, I can. Okay. I'm going to be completely honest with you guys. There is a way of doing this, but, and I'll go through it with you, but you might see that it's faster to just to do it the, the cheesy way. So when you're finding the cube roots, you have to do two things first. You have to do one thing which has two parts. You have to find the equation of your complex number in a form called r cis theta. And sort of the reasoning behind this, right? You have your maybe you know, maybe you don't. Complex numbers are basically just like two-dimensional numbers, right? You have a real part and you have an imaginary part. And so when you have a complex number, say like right here is if this would normally be the coordinates like 2 comma 1, it would just be 2 plus I, right? That kind of thing. So if you have an angle theta and a magnitude of r, then you can see, drawing a right triangle, that the real part is r cosine of theta and the imaginary part is r sine of theta, right? So putting those together, your complex number will be r times the cosine of theta plus I times r sine of theta. And the way they'll abbreviate this is, well, if you factor out the r, it's r cosine theta plus I sine of theta, which they'll just abbreviate as r cis of theta. Cis being c cosine I sine. Right, so you have to find r and theta. So r is just the magnitude of your complex number. So the magnitude, we have the real part of -8 and the imaginary part of -8 squared of 3i. And so you can imagine if your x part, like this, is 8, and okay, obviously this is in a different quadrant, but if you have 8 and then your vertical part is 8 square root of 3, then the way you find your magnitude is just with the Pythagorean theorem. When you do this, I believe it gives you 16, but I'm going to double check that. Yes, it gives you 16. And then you have to find your angle, which you can use the formula tangent theta equals, normally it would be y over x, but for this you can use imaginary over real to find your theta. And because we're in, so -8 minus 8 square root of 3, we're going to be in this quadrant. So we're going to be between 180 and 270. So keep that in mind whenever you're finding theta. So it'll be an angle theta equals 240 degrees. So when you're writing this out, you get z equals 16 times the cosine of 240 degrees, not cosine, 16 cis of 240 degrees. Well, so that's kind of the hard part. Then it says you want to take you need to find one of the fourth roots of that. So there's a general formula. This is called Demov's theorem. If you want to look this up later, if you have a complex number r cis of theta and you raise it to a power, it has the effect of raising the magnitude to that power and then multiplying theta by that exponent, like that. So if I'm taking the fourth root, right, z to the 1/4, that's going to take 16 to the 1/4, which is just 2, and then take 240 and multiply by 1/4, which is 60. So you get 2 cis of 60 degrees. And you know how, like, when you take the square root of a number, say like 81, and people say, what's the square root of 81? You say 9, and they're like, it's actually 9 and -9. You got two values. So the same way that when you take the square root, you get two values, when you take a fourth root, you actually get four values. When you take the third root, you get three values, right? There's other things. And these happen to be evenly distributed around the circle. So what does that mean? So 2 cis of 60, magnitude of 2, angle of 60 degrees, right? Well, if you're evenly distributed around a 360-degree plane, right, 360 over 4 is 90. So each of these are going to be exactly 90 degrees apart. They're all going to have magnitude of 2, but they're all going to be 90 degrees apart. So what this helps you with is it's 2 cis 60, 2 cis of 150, 2 cis of 240, wait, yeah, and 2 cis of 330. Right? And then when you want to, and sometimes he'll set up the problem so that your answer choices are actually looking like this. But in this case, he left it out in like the expanded form. And so you would have to do all this and then evaluate each of these, which is, I don't know, that's kind of slow. So what I ended up doing on this test actually is just taking answer choices and taking them to the fourth power until I got -8 minus 8 squared to 3i. Just because this process takes a while. There might be a way to do it on the Inspire. I'm not sure. There might be like a complex solver. If anyone knows about that, that would be nice for you guys to say something. But we have 6 concurrent viewers right now. Oh, just went up to 8. Sweet. Okay. So, yeah, so 32, if it gives you like insist, I guess, you should probably do it this way. Because honestly, this doesn't take too long, especially if you're comfortable with it. But like on 32, whenever it doesn't give you the sys, whenever it's still expanded all out, it's just kind of annoying to do all this and then have to re-expand it. Yeah. So, what do you guys want to see next? We can probably do a handful more. We go over 38. You bet. Oh yeah, this question, yeah. Yeah. I can definitely go over number 38. Maybe while I'm explaining this, I'll find a quicker way, because this question kind of took me a while. Okay, a circle with center P has a radius of 6. Okay, this is question 38. Circle with center P has a radius of 6 and is externally tangent to a circle with center O, which has a radius of 9. So that's circle O. Points A and B lie on circle O. From P, tangents PA and PB are drawn to the center. Okay, so we're going to have these tangents. So that's at A, and that's at B. Okay, find the area that is inside the kite PAOB, but outside of both circles. See, this is like, man, take it easy on us, okay? All right. All right, so what do we know? So we know that the radius of the little one is 6, and the radius of the big one is 9. So far, the best way I figured out to find this area is to just find the area of the kite and then subtract out the area of these little sectors. So to find the area of the kite, what I did is I split this in half. I split it like right down the middle. And then I was able to find, because the tangent and the radii are always going to be perpendicular, right? These are right angles. I know that that is 9 and that's 9. And I know that this length PO is just the sum of the two radii. And so I can use the Pythagorean theorem to find out what PA and PB are. I'm pretty sure they were just 12, yeah. So that's 12. So you can find the area of the kite pretty easily. The area of like one of the smaller triangles is 12 times 9 over 2. And then just double it because there's 2 of them. So the area of the kite is 108. Yes. But it wants the area that is inside the kite but outside of those circles. So you have to subtract out both of these circles, which is kind of the annoying part. So for the sector on the left, you have to find what this angle is. And say, well, theta over 360 times pi r squared. Ooh, okay. So on the inside, yeah, you have to find what this angle is. Which, it's kind of nice that we've already split this up into 2, because now you can find what this angle is, because you have the sides of this triangle. So So I don't know. You can use sine, cosine, or tangent. It really doesn't matter. I think I used sine during the test. So opposite over hypotenuse. So inverse sine of 9 over 15 gives you 36.87. So this angle here is 73.74. And then use the same logic um, to find this angle over here, right? Well, also, you can use the fact that you've already found this one. So if that's 36.87, then that angle would be 180 minus 36.87 minus 90, and then double it, because you got two of them. So that's going to be 106.26. So the area of the sector on the left, 73.74 over 360 times pi r squared. And then the area of the sector on the right, 106.26 over 360 times pi times 9 squared. And whenever you subtract out all of these, get, bear with me for a second, get 9.7. Alright, hopefully that all made sense. Hopefully I didn't skip too many steps on accident. Alright, so that's number 38. Okay, so it's almost 7:50. So what we're gonna do, if anyone has any more questions, not a lot of people are asking about statistics. We had that one question about statistics, but if you guys want to see any of that stuff, um, yeah, if you guys want to see any of that stuff, then that's how my coach showed us in practice. Yeah, I wish there's an easier way to. I'm gonna keep looking, but yeah, I'm gonna keep looking. I'm gonna go over this test a lot between now and state, but that's the fastest way I've been able to figure out. Yeah, it's rough making programs for this guy. Whenever Larry White was contest director, his questions didn't really change much, and so programs were really heavy. But especially district, region, state, he really switches up his problems a lot. So it's really hard to like predict what he's gonna do. So I'm not, yeah. This test was just meant to take a long time. My best advice for those of you going to state, um, is I would practice geometry a lot, actually. Because I don't know about you, but maybe this is just me. But the part of this test that slowed me down, the reason I didn't do as well on this one as I did at district, is just because the geometry just slowed me down a bunch. It just took forever. So that's definitely what I'm going to be working on. Because yeah, you can know how to solve every question, but if you can't answer every question, then it doesn't really help you that much. Okay. Any other problems that you guys want me to go over? There's the mean value theorem. Are you guys in calculus, by the way? Just curious, because that might be why you guys aren't asking. If you guys aren't in calculus, then you're not really gonna get a lot of these ones, even if I explain it. There's just too much background. There's distance from a point to a plane. You guys, that's a good one to know. Point to a plane. Um, Focus and directrix. Oh, you're in Calc 3. Okay, never mind. You're, yeah, you're doing pretty well. Never mind. Well, is that a dual credit sort of thing? Oh, you're in Calc 2. Okay, so you guys are doing just fine. Yeah, I don't know. Is that like a dual credit thing? Does your school do that? Because I don't know about you, but my school only offers Calc AB. All this extra stuff I've had to learn on my own, and learning Calc 3 on your own is pretty tricky. I say on my own. I do it with Khan Academy. basically a superior teacher. Did you guys all get 29? What about statistics? Have you guys taken statistics? Yeah, dual credit. Yeah. How do you do 44? Let's see. Oh, okay. Solid revolution is one that I have made programs for. So I haven't actually looked too closely at this one, but let's see what we can do. So f of x equals 0.2 times x plus 1 squared plus 10. G of x equals 0.4 x minus 1 squared minus 4. Okay, so 42 is find the volume of a solid generated in the region bounded by the graphs revolved around x equals -6. Oh, you gotta use like shell method, don't you? Well, I need to refresh on these formulas. Okay, first thing you have to do is just find when do these intersect? Because you're gonna need that for the bounds of integration. So it looks like they intersect at, did I type that right? X equals -5.83, x equals 11.83, and then okay, what does this look like? I'm really struggling on my axis drawing today, aren't I? Oh my gosh. Just go straight down. It's not that hard. Okay, so f of x looks something like this. And then what does the other one look like? Oh wait, no, it's negative point. Wait, hold up. Give me 1 second. Sorry, I messed that up. Misread the problem. Okay, that's what I remember the bounds being. Um, -4.4 and then 5.07. Okay, so what does this graph look like? Okay, so something like, okay, that's f of x. And then g of x looks something like, um, drawing is harder than you think. Something like that. Okay, it's whatever. My drawing skills are not fantastic. And then x equals -6 is something like right here. See, my drawing skills are struggling right now. Okay, there is our shaded area. There's the shell method. I'm trying to think what our formula is for shell method. Um, oh yes. I remember. So it's going to be the what? Hold on. What happens when you use programs, guys? You forget stuff. Oh, yes, I remember now. So you integrate on your bounds, um, multiply by 2 pi of your of x minus your axis. So in this case, it'll be x plus 6 times the difference in your equations. So negative 0.2 times x plus 1 squared plus 10 minus 0.4 times x minus 1 squared minus 4 dx. Yes, that's what it is. Oh, it's coming back to me a little bit. It comes from like you get a bunch of cylinders, and then that's what you're integrating. You're integrating like all your cylinders, and that's why it's shell method. Okay, yeah, it's coming back to me a little bit. It's like all your surface areas of your cylinders. Yeah, yep. And then when you add all those, it gives you the volume. So let's see if this gives me the right answer. Sometimes there's so many formulas in calculus that like you just can't remember them all sometimes. Um. Oh shoot. Oh, it's because I used -2 instead of -0.2, and I still didn't get it. Um. Dang. This is a little bit of a bad way to end a stream, but at least now I know that I need to review this. Okay, we're gonna get this. I'll figure out what I'm doing wrong. I bet. Oh, I know what it is. Wait, no, that doesn't make sense. It's supposed to be your axis minus x. Oh, try this. It's great. -6 minus x. Actually, will this even matter? Or am I just gonna get the negative? Yeah, I'm still gonna get the negative. I don't know why I'm blanking on this. It's a little bit embarrassing. Oh, I know what I'm doing wrong. Dang it. It's just my syntax. There we go. Okay, so I was giving you guys the right thing. I just had the syntax wrong. That's annoying. Okay. Alright, so at least we got it at the end. 3385. But yeah, this is definitely one I would make a program for, especially for those of you that do calculator, because this kind of thing comes up all the time. All the time. Alright, well, this was fun. We went from 6:30 to 8 o'clock. I feel like we got some good stuff in. Hopefully you guys learned something. Um, yeah, making programs definitely helps, but just just be careful about forgetting certain things because um, he could very easily make a question that says like, what formula would you use to solve this equation? Like how we did with the arc length. Um, Silly question, but how do you get those bounds? My calculator told me the intersections were -4.28 and 5.28. Um, oh, all I did was just set these two equations equal to each other, right? Because if when they intersect, their y's have to be the same. So f of x equals g of x, and so I set this equal to this. Maybe just check, make sure you typed it in right. Because I got the right answer with those bounds, so I'm pretty sure those are correct. Unless I got just extraordinarily lucky. Tell me if that works. Maybe? Okay, yeah, there's probably a typo. You probably forgot like a negative or something. I don't know. Well, anyway, hope you guys enjoyed this. I'm gonna try to get my hands on the calculator applications test and also the number sense test. Try to get the PDFs of those. If you guys will send those to me on the Discord, that would actually be really helpful. And I would be able to do live streams over those. I could afford to do the math without the PDF just because you guys are able to keep your tests. But if I do it with number sense and calculator, enough people won't have access to those yet, just because I don't know, maybe they haven't like gone and picked them up. That having people that I would risk having people that didn't have the test. But hopefully you guys learned something. We're gonna call it quits. So I'll see you guys later.